Good day, everyone. My name is Zhong Huiping. I would like to talk about first and second law of thermodynamics. So basically, the first law of thermodynamics is subjected to the principle of conservation of energy, in which, according to the first law of thermodynamics, energy cannot be generated or destroyed throughout the process. However, it can be changed from one form to another form. So, in other words, energy can be altered or transformed from a system to the surrounding, but is conserved in all process. Based on the principle, the totality of the heat being added to the system, which is denoted by the Q, and the entire work done by the system, W, is equal to the total change in the energy, which is denoted by the E. So this equation shown below is the formula of the first law of thermodynamics. And for an example, the increase in the energy of a potato in an oven is equal to the amount of energy heat transferred to it. Furthermore, it doesn't matter whether the energy crosses a boundary as a heat or work. So the amount of energy that does so is equivalent to the change in the system energy content. An example related to our daily life is boiling water. For example, the 10 kilojoule of heat is transmitted from the heating element to the water during the boiling process, while 2 kilojoule are lost to the atmosphere. So as a result, the energy increment of the water is equivalent to net heat transfer, which at kilojoule. Next, based on the example stated above, so the situation can refer as energy balance, where the difference between the total energy entering and the total energy leaving the system throughout the process is equal to the net change in the total energy of the system. Also, energy is said to be can be converted, where, for instance, when the driver presses the car brake to slow down the vehicle, energy formed when motion is posted is called the kinetic energy, is converted to the thermal energy, which is heat, causing the brake disc to heat up. Based on the first law of thermodynamics, it provided an extra variable called enthalpy. So it's sometimes used as the definition of internal energy. So in addition, since the first law of thermodynamics stated that energy could present in plentiful forms in a system, so the sum of the energy make up the system is called the total energy, denoted by the E. So for process without the electric, magnetic, or surface intention, a system total energy changes equal to the summation of potential energy, kinetic energy, and also the internal energy changes. However, if the system does not apply any changes in elevation and velocity, so we can assume it as a stationary system and denote them as zero. So the energy change of stationary system can be reduced to E equals to U. On the other hand, heat transfer, work transfer, and also mass transfer were the energy that can be transferred in or out for a system. So the net transfer, or known as the quantity, is the difference between amount of energy transferred in and also the amount of energy transferred out. Next, when heat is transferred to a system, heat is gained. So the molecular energy and the system energy will increase, and it can be denoted as positive heat transfer. Positive Q indicates that the system absorbs heat. So as opposed to that, the negative Q is used when the system produces heat. For work, when the work is transferred to a system, not as work done on system, we can denote it as positive W. For negative W, which means the work is done by the system. So anyhow, mass flow may or may not pass through the boundary of a system. So depending on the type of the system, which means in closed system, only heat transfer and work are being transferred. Okay, the next one is about we need to consider, could the water get hotter when placed in a cooler place? So relative to the first law of thermodynamics, the energy gained by the surrounding air equals to the energy lost by the water. However, we need to think of it. Is the process reversible? Which water could get hotter when placed in a cooler place? If this occur, it will not go against the first law of thermodynamics as long as energy obtained by the surrounding air is equal to the energy lost by the water. So to make it clear, the second law of thermodynamics is introduced to address the criticism of the first law of thermodynamics, where there's no sufficient to determine whether a process can occur. So in first law, there's no limits on the direction of a process being imposed. Hence, the second law is introduced, which the energy is transferred or transformed, more and more of it is wasted, meaning that the second law of thermodynamics describes heat and energy in conversions, which based on the findings, fully converting the work direct to the heat is attainable. Despite that, heat could not change the work naturally except with the help of devices such as heat engines. So the fundamental of heat engines is indicated in this figure, which it will converting some of the heat energy from for work and we're discarding the remaining excess heat to a sink with a lower temperature. Heat is always flow spontaneously from higher to lower temperature. Next, based on the second law of thermodynamics, it can be divided into three. The first is the Kelvin-Planck statement, where no device could do a net quantity of work by simply working on a cycle and receiving heat from a single reservoir. So there's no 100% thermal efficiency in a heat engine. For one example that I can give is a boat engines can't work by extracting the heat from the ocean. So in other words, in a heat engine, heat cannot convert into work ultimately. This means that the heat received from the reservoir will not convert it into work truly. So this doesn't apply in the Kelvin-Planck statement. And the second one is Celsius statement. A spontaneous transfer of heat from a body with a lower temperature to a body with a higher temperature is not conceivable by itself. So according to this claim, a refrigerator cannot function without an external power supply such as electricity, so to drive the compressor. So the consumption of some energy will disperse to the surrounding. And the last one is the Carnot cycle. Since the second law of thermodynamics declare that no heat engine can obtain 100% efficiency, however, it's proof that a reversible motor has a higher efficiency than an irreversible engine. So process that we are going to discuss is about reversible, in which it will return to its initial state without leaving any traces behind. And the Carnot cycle can be divided into four, which is two adiabatic and also two isothermal. Next, I will talk about refrigerator. Another refrigerator is another device that operates in accordance with the second law of thermodynamics. So the refrigerator first enters the compressor as a vapor and then is compressed into the condenser and at a relative of high temperature. So the refrigerant will condense and cool down in the condenser by rejecting heat to the water passing through the condenser coils. So the lower temperature refrigerant then enters the evaporator here by absorbing the heat from the refrigerated space and evaporating from the evaporator as a gas and flowing back to the compressor. So the refrigerator consists of four primary components, which the evaporator, expansion valve, condenser, and also compressor. Next, I will talk deeper about the Carnot cycle. The first one, from point 1 to point 2, is known as reversible isothermal expansion, where the gas expands slowly from point 1 to point 2 at a constant temperature. And supposedly the temperature would tend to decrease when the gas is expanding. However, a total amount of heat, which the QH, is transferred from the reservoir into the gas, making the temperature remain the same. So the next is the insulation will be installed in the system, leading to a reversible and adiabatic process. So temperature tends to drop from TH to TL, this process known as reversible adiabatic expansion. So the third one is reversible isothermal compression. The temperature throughout the process is constant, which TL. When the gas is compressed, it tends to cause the temperature to rise. However, when the temperature rises, the heat, which the QL, will be rejected from the gas and transmitted to the sink. And finally, returning to the point one from point four, the process known as reversible adiabatic compression, which completes the cycle. When the low temperature reservoir is taken off, the cylinder head insulation is reinstalled here, and the gas is compressed reversible, and the temperature increases from TL to TH. So the gas will back to the initial state. So these two figures indicates the difference between the Carnot cycle and the reverse Carnot cycle. Actually, the difference is only the direction of the heat and also the work. Thermal efficiency. Thermal efficiency of a heat engine is a measurement of how well the heat is received and is converted into the work. So all the reversible heat engines are considered to have a light thermal efficiency. However, for the Carnot cycle engines, the temperature ratio depends on the heat transfer ratio between a reversible heat engine and also the reservoir. Hence, the Kelvin scales in employed. So these two equations are used to determine the thermal efficiency. Next is coefficient of performance, where it indicates the performance of a heat pumps or a refrigerator. In addition, the value of thermal efficiency and the COP of reversible heat pumps and refrigerators have achieved the maximum with the temperature limits with the TH and also the TL. So this slide have shown the COP of the refrigerators for both reversible and also the normal one. Okay, so in conclusion, to sum out that the first law and second law of thermodynamics hold a different concept of law, where first law only consider the quantity of energy and how it changes from one form to another. However, the second law offer the tools needed to assess both the quality and also the efficiency of the energy used in a process, in which engineers are very concerned with maintaining the quality of energy. Next, both are important to enable people to utilize energy efficiently, where want to avoid the unwanted usage by knowing how a system can change and function. For example, more efficiency, better insulated, and more environment-friendly refrigerators are now being innovated by employing the knowledge of the second law of thermodynamics. Lastly, the law of thermodynamics play an important role in thermodynamics. So knowing the laws, it helps us, especially engineers, to understand the concept of energy and enabling us to design and operate a system better and have a higher performance, which help to modernize the world. So that's all from me. Thank you.